given 2 points A and B. We want to find the coordinates of point P that could partition this line in the ratio 1, 3. So just like all these other problems, go ahead and plot these points. 4 and 6, negative 8. Next. Okay. Don't worry about these right now.
It's impossible for me to remember these things if I don't have them on paper.
Okay, we'll worry about that later. Let's just focus on getting these done.
So we do steal them.
Oh, I don't worry about that later. So now what you want to do, find your change in Y, your change in X. Okay. Oh, find your change in Y, you just count. And when we count, how far do we go? What is it going to be? Good. Why is it negative 12? Because we're going down 12, so it's negative. Now find your change in X. We'll count over. How far do we go over? And we went to the right, so it's positive. So make sure you follow those sign rules. If you go down, negative, left, negative. If you go up, it's positive. Or if you go right, it's positive. What are we going to divide these values by? 4. How did you get 4? Good. Add that ratio together. So we're going to divide by 4. When we divide by 4, what's negative 12 divided by 4? 3. What's 8 divided by 4? Right, when you get those values, you're going to add them to the point you started with. What point did we start counting from? Negative 2, 4. We started counting from A. We're going to start with A. And then add what you got with the X to the X value. And add what you got with the Y to the Y value. Or subtract if it's negative. And you're going to keep doing that process till you get that second point. Right? So we combine that. What's negative 2 plus 2? 4 minus 3. 1. Alright. Again. 0 plus 2. 1 minus 3. Alright, keep going. 2 plus 2 is 4. Negative 2 minus 3 is 5. Again, you're going to keep going. What's 4 plus 2? 6. And negative 5 minus 3 is negative 8. Can we stop? Yeah. Got our second point. So that's going to tell you you can stop. Okay? I like this because it tells you whether or not you're doing this problem wrong. If you kept adding values and you never reach your second point, if you notice, hey, I'm not getting anywhere near the second point, that's telling you that you did something wrong somewhere. So either you accidentally had the wrong sign, you divided by the wrong parts, some little error, you started with the wrong point, that's indicating to you that you have to go back and check your work. That's why I kind of like this, because you know if you're doing it right or not. You know you did it right if you get the second point. Okay? So once you do that, you have to figure out how many jumps you're going to make. How many jumps we're going to make in this problem. Yeah, how do we know we're only making one jump? Ratio. So always the first number in your ratio. So 1 is the first number. So you start with the first point and make one jump. That's going to be point number 1. Okay? Repeat that same process with your second point. Start with the second point. Make a jump. And that's going to be your second point. So we'll move it aside. Questions over that? Since to stay present every single time is dealing with different numbers.
All right. Good about that. Same process. You'll do it over and over again. Let's try this guy. All right, give him the points there. Find the quantum speed, that ratio of 1, 2, 3. All right, let's get it. So it means we're going to plot our point, as everyone should. If you will leave this blank on today's little assessment and Friday's test, you're just trying to not help yourself out. So let's see this here. A, -3, -2. Right there, A. B is at 4, 1, 4, 1. B. That's the segment I'm trying to partition. So let's go ahead here. Just like we've been doing, we're trying to find the change in y over the change in x. First step here. This is where we make that little triangle. Really what you're doing is you're finding the slope, guys. So if I'm going from A to B, I have to go up or down first because I'm doing y. How would you tell me to get from A to B? Where do I have to go? Up. I have to go up. That's correct. So how far up do I go? 1, 2, 3. So because I went up, that makes it a positive. This is a positive 3. Well, let's now do B. If I go up 3, how far over do I have to go to get to B? Let's do a little counting. 1, 2, 3, 4, 5, 6, 7. 7. So I have a slope of 3 over 7. Great. I'm going to have to figure out what I'm going to increase all of these points by. So I'm going to divide these numbers, those changes in y and x, by the total number of partitions in the segment. How many pieces am I cutting this line up into? 4, right? How do you get that? You look at the ratio. You take those two numbers, add them together, that tells you how many pieces there will be. In this case, 1 plus 3 is 4. So this is what I'm increasing them by. Now, do these reduce? Does 3 over 4 reduce into a nice, beautiful number? No, it's still going to be a decimal. Same thing with 7/4. It's still going to be that ugly decimal. Keep it as its fraction. It's fine. We can add fractions on your calculator. If you don't have a calculator, you're going to need one to practice these skills to understand it. So if you want to get one right now, go for it. But now that I know what my points, my increases are going to be to each of the points, I'm going to start with my first point. That was A. So that's going to be at -3, -2. I'm going to have to add these changes to each of the points. One thing is this, make sure you know that in the ordered pair, x comes first, y comes second. And that when I do this, I'm going to add the y, this 3/4 to the -2, add 7/4 to the -3, then continue on. My ultimate goal is to keep adding those values on until I get back to my second point. That means I'm done. So let's go ahead. I'm going to add 7/4 to this one. I almost put it backwards. I'm going to add 3/4 to this one. And that will give me a new point, possibly. So when I do -3 plus 7 over 4, I get what? -5/4. Very good. Do that calculator, -5/4. All right. Again, if you need to, what's it say here? Practice skills with your calculator. So let's try to think it here. All right, -5/4. All right. What about the next one? -2 plus 3/4. Also -5/4, right? Huh, that's pretty cool. The same. But are -5/4, -5/4 the same as our second point? Are they the same number? Got to keep going. So again, I'm going to add another 7/4 to my x value and 3/4 to my y value. Let's roll. -7/4. Oh, that's nice. They both have a common denominator. The math's a little bit easier. So really, it's -5 plus 7. What do you get there? -5 plus 7, or 7 minus 5? 2. What's 2 over 4? 1/2. So we're just down to 1/2. Okay, cool. The next one over here, again, same common denominator. What's -5 plus 3? -2. -2 over 4 is -1/2. All right, let's change it a little bit. But again, that point is not the same as our second one. We have to continue on. So I'm going to add 7/4, add 3/4. And let's see what I get. I think these parentheses big enough. All right. What is 1/2 plus 7/4? 1/2. Again, if you're borrowed calculators, ABC it up. If you're using TIs, ABC it up. All right. I get what? Cal, what did you say? 5/4. 9/4. 9/4. All right. What is -1/2 and 3/4 together? 1/4. Positive 1/4. Great. Still not there yet. Gotta keep going. And I know this is going to be my last one. So plus 3/4. 9/4 plus 7/4. They're the same number. 9 and 7 is 16. 16 divided by 4 is 4. Same denominators. 1 plus 4 is 4. 4 divided by 4 is 1. And you get a good time your calculator. Man, how did I know this is going to be the last one before I did it? Because some of you say, how do I know how many times I have to keep adding these points? Does anyone ask that question? Like, feel like I'm doing this forever? Well, here's an easy trick. What's the total number of partitions in a segment? 4. All you do is add one more, and that tells you how many points there will be. So there's 4. 4 plus 1 is 5. There should be 5 points. 1, 2, 3, 4. One down there, 5. It's 5 points. If there's only 3 partitions, that means there'll be 4 points. So just a helpful way to know when you're done. If you keep going on more than that, you probably messed up your increase up here. It will change the y and x. All right. So now we're done. We've got all 5 points. We just got to figure out which points will satisfy this ratio. 1 to 3. How many jumps are we going to make? 1. Whatever that first number is right there, that's how many jumps I make. Go to the first number, jump 1. Go to the back number, jump 1. That will give me my 2 points that satisfy this. So point 1 and point 2. All right, point 1. If I go to my first point, make 1 jump, I come to, boom. There's my first point. That will satisfy that partition. So -5/4, -5/4. 1. The second one means I have the last number. I go to the last number, and how many jumps do I do here? It's also 1. So I go here, do 1 jump. There's my second one. 9/4 and 1/4. 9/4. Same exact thing. Fractions doesn't really change it, other than just the numbers a little more difficult to work with sometimes. But you have a calculator, makes your life a lot easier. Questions on that? Everyone's going to get 100% on this little mini quiz.
In recap, problem number 3. Kind of jumped ahead before recording. Go ahead, plot these points, label and connect them. And we're trying to determine if this is a trapezoid. And what do we know about trapezoids? What's special about them? That's parallelogram. What's different about a trapezoid than a parallelogram? Okay? Yeah, there's only one set of parallel sides, so we have to show that only one set of these sides are parallel and the other set is not. So pick any side. It does not matter. Pick any. What side do you want to start with? A what? AT? Okay. That was AT. Go ahead and find the slope of AT. Can we do that? 1, 2, 3, 4, 5. We went up 6. And over. How far did we go over? That's -6 because we went to the left. And what does 6 over -6 reduce down to? -1. Right? Repeat that same process for the side directly opposite of AT. So for MH. We find the slope of MH, count down. How far do we go down? 6, but we went down, so it's going to be negative 6. Count over. How far do we go over? And that reduces down to negative 1. So we're good. Right? We have one set that's parallel. Okay? You can't stop here and say it's a trapezoid because you have to show that the other two aren't parallel in order for it to be a trapezoid. So find the slope of the other two sides. Find the slope of MA. So count up. How far do we go up? 5. How far do we go over? 3. The slope of MA is 5/3. Find the slope of TH. How far do we go down? 5. We went down, so it's going to be negative 5. How far do we go over? Negative 3, because we went to the left. A negative over a negative reduces down to a positive. Huh. What do you notice about these sides? They're the same, so those sides are also parallel. So can this be a trapezoid? No. You can only have one set of sides that have the same slope. The other set has to have different slopes. So what is this then? It's a parallelogram. So no, it's not a trapezoid. Not a trapezoid. Because it's a parallelogram. You want to make a note to help you study? It can only have one set of parallel sides. It has two sets of parallel sides and parallelogram. Not a trapezoid.
Go to that. Find if the sides are parallel or not. Well, we're going to continue that theme with this next one. Determine if the quadrilateral with the following vertices is an isosceles trapezoid. Justify your answer. Okay. Well, let's go ahead and graph this out. Plot the points. -4, -3. Right there. We're going to call that guy W. The next one is 0, 3. Okay, that's X. Next one is 4, 3. Call that Y. Now my last one is 8, -3. And why not? We'll name that one Z. Connect those dots. You got something that looks like that. Well, I know what some of you are already thinking, but is there something nice about this shape relative to the other one? Yes. Yeah, the one you just easily count where they're at. I can see if they're parallel or not. We're still going to include it just to say, status quo with everything. But those two sides are the ones that go exactly on the line. And those are XY. I didn't change my color for some reason. Those are XY. And the other one is WZ. What is the slope of XY? How high up do I have to go? 0. How far over do I go? 4. So it's 0, 4. Anytime I have a number divided by 0, or 0 divided by a number, it becomes 0. There's no slope. It's not going up or down. All right, that doesn't work out. What about the bottom one? How high up do I have to go? 0. Same exact kind of thing there. We know it's going to happen. But we'll do this for the sake here. We'll count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we know what's going to happen there. It's also going to be 0. Okay, so do I have a pair of sides that are parallel? Is 0 parallel to 0? Yeah, they are. I agree with that. So we got to determine if those other lines are not parallel. It may appear that they are, but we have to double check that. So let's go ahead and find out what WX is. And while we're finding WX, we're also going to find YZ. Why? So I said so. All right, WX. Well, let's find the slope of this guy. So start at my W. Where do I have to go to get X? Up or down? I have to go up. 1, 2, 3. How far did I go up? 6. How far did I go over? 4. Up 6, over 4. All right, cool. Can 6 over 4 reduce? And what's the reduce to, Lauren? 3 over 2. I agree. All right, well, let's look at the other one. Let's look at ZY over here. If I had to go to Z to Y, where do I have to go? Up. 1, 2, 3, 4, 5, 6. 6 over 1, 2, 3, 4. But I went to the left 4, so what's that mean? It's negative. So an up 6, negative 4. 6 over 4 is the same number, but it's now going to be a negative 3 over 2. Are these two sides parallel? No, they're close because they're opposite, or they're opposite, meaning one's positive, one's negative. But are they reciprocals? Are those fractions flipped? No, they're the same exact fraction. So no. So guess what? We do have a trapezoid because these are different. That means it is a trapezoid. Good. But isn't it isosceles trapezoid? How do you figure that? Well, we know that the things in between those parallel sides, we call these legs, just like in a triangle. These ones right here are the legs. And just like in isosceles triangles, what do we know about legs of isosceles trapezoids? Specifically, their measures. They're congruent. So all we got to do is figure out how long these sections are. So we want to figure out the distance of segment WX, and we want to figure out the distance of YZ. Well, let's do it. How do you figure out how long this is? Well, you kind of already did a little bit of it. To find distance in this this unit we've been doing with graphing coordinates and everything, what formula do we use to find distance of things? The Pythagorean theorem: a squared plus b squared c squared. And you can already see the triangle we made up here on the left side when we're finding WX. Looks like it went up 6 over 4. So those are going to be my the legs of my triangle, and we're going to find our c value. So I'm going to do 6 squared plus 4 squared is equal to c squared. 6 squared is 6. 4 squared is 16 equals c squared. 16 and 36. 52 equals c squared. Get c by itself, I have to square root, the root's on fire. So c is equal to the square root of 52. Now I could get that as a decimal, but I don't really care because I'm just comparing lengths. Just comparing lengths there. Alright. Do you notice anything about YZ now that we find YZ? What do you mean they're the same thing? What do you mean by that?
Same numbers.
They are the same numbers. I went up by 6 on the left side, I went up by 6 on the right side. I went over 4 on the right side, I went over 4, or on the left side, I went over 4 on the right side. Yes, I know we went negative, but again, remember distance, it doesn't matter if it's negative or positive. If they both have the same numbers, what do you think their answer is going to be? The same, right? Different? I don't think so. In the bizarre world, they won't be. So those are also square root of 52. So are those legs congruent? Yes. So we now call this an isosceles trapezoid. So now I just proved it. And I'd say yes, it's isotrap, because I have only one pair of parallel sides, and the legs are congruent. Reasoning. Shift to one side parallel, figure out those sides are the same. Questions with those? Oakley dokley. Moving on to number 5. Ooh, blast from the past.
From last quarter, last semester we have problems just like this. They will be on your test. Find the equation of a line that is parallel to the line y equals 1/2 x minus 7 and passes through the point 12, 9. When we write the equations of a line, what form are they in? Y equals mx plus b. So the two things we need to know what our m is, and we need to know what our b is in order to write the equation of a line. Do we know the m of our new slope, or of our new line? What does m stand for? Slope. Do we know the slope of our new line? Yeah, what is it? What is it? 1/2. Good. We're going to use the 12 and 9 here in a second. But we know the slope of our new line is 1/2. Why is it 1/2? Yeah. Perfect. Whenever you see parallel, say same slope. So those lines are going to be the same. The slopes are going to be exactly the same. So whatever the slope is of the first line, that's going to be the slope of your new line. Here's the thing. Do we know the y-intercept? Did they give us the y-intercept of our new line? No. It's tempted to say that it's -7, but that's the y-intercept of the old line. The new line is going to have a completely different y-intercept. Right? We don't know what our b is yet. So far, this is all we have for the equation of our line. Well, is there something we can do at that point to help us figure out what our b is? Aaron, what can you do? Yeah, plug in 12 and 9. You can plug 12 in for x and 9 in for y. 9 goes in for y, 12 goes in for x. And when you do that, that makes b the only variable. So you can easily just solve for b. So clean it up. What's 1/2 times 12? And what do we have to do with the 6? So to get that b is equal to what? So we have our b, we have our m. That's not our answer. We want an equation of a line. So you just take these values and plug it in here. So 12 goes in for m, or sorry, 1/2 goes in for m, 3 goes in for b, and x and y just stay x and y. You no longer need that point. Questions over that? So you'll see ones like this on your test on Friday.